Hi, today we're going to talk about deriving the future value of an annuity formula. An annuity is a recurring set of cash flows that you receive, and the way to calculate the future value of it is to consider the amount of interest that you're earning on each of the cash flows throughout the annuity. This is useful in finance because you deal with annuities quite often, and this video is going to show how to derive the formula to get the future value of an annuity. I've also attached a spreadsheet which has the calculations and you can use. It's in the link below. Also, it's with the other Street Smart resources that you can check out. I'll go through the spreadsheet at the end of the video though. For now, let's focus on the theory behind this. How do you get the future value of the cash flows? So let's get started. The way to think about this is to focus on thinking that the cash flows are going to be invested in individual bank accounts. So pretend that we had a cash flow here at time 1. We received $100 or whatever, and we're going to put this money into a savings account, and that's going to earn interest in year 1 to year 2, and it's going to earn interest from year 2 to 3, and so on until we get to our final date at the very end when the annuity is over. Well, that's all right. That sounds good. What about when we receive money from our year 2? Well, we're going to put that into a savings account, another savings account, and that's going to receive interest every single period until we get to the future value. And you're going to keep doing that for every single one of the cash flows. All right, so that sounds like a pain to do by hand. And you're right, that is a pain to do by hand. But we can make some interesting observations, and you'll see why in a second. The way to start is to think about this backwards. So in the last period, we received some money here, and we're going to receive interest for just one period, only one. So what is that? Well, that is going to be for just one period. So our cash flow times interest for one period. And then what about the second last period? Well, that's going to be earning interest for 1, 2. So that's going to be earning interest for 2 periods. And that's going to continue on all the way to here. Well, what do we have for these sections? Well, this is going to be n periods minus 2, right? So that's going to be n minus 2, and then n plus r n minus 1. And assuming that we don't receive any money in the beginning, that's where we'll stop, because it will start receiving money at this point. Well, what can we do with this? Because this would take a long time. This could be, n could be 10, could be 20, 30, 40. This could be a lot in between here, and this could be a lot of terms. You don't want to be doing this by hand. You want to do this either by spreadsheet or by a formula. Well, what can we do here? Well, we see that this looks kind of familiar, and it is because it's a geometric series. And a geometric series, I've explained it in another video, but you end up with the formula like this. This is the sum of terms. This is your term, this is your common ratio, this is your number of periods. We think of finance here, and this is A is our cash flow, R is our interest rate, and N is our number of periods. How can we prove that this is a geometric series and that we can use this formula? Well, the way to test for a geometric series is to divide a term by the preceding term and to see if there's a common ratio between them. So we can do this. Let's use another color. So we can have a to the 1 plus r squared divided by a to the 1 plus r. And we see that we actually receive a common term out of this, and that's 1 plus r. Now, I'm not gonna do this for all of a bunch of terms. I don't see the point of that. But you can get the idea that there's a common ratio between all these terms. And you can do that, and you'll see that there indeed is, and that is 1 plus r. That's our common ratio. So we know we can use the geometric series formula. So if we were to plug this in to our geometric series formula, what do we have here? Well, we have 1 minus, and now we're going to substitute in our common ratio, which is 1 plus r. So that's to the n. Oops, I need another bracket there. N. And then divided by 1 minus our common ratio, which is 1 plus r. So now we can simplify this a little bit. We can cross out some things here. We can see that the 1s are going to cancel out. So we get 1 minus 1 plus r to the n divided by, well, that's going to cancel out. So we're going to have negative r, left with negative r. You don't really want to leave a negative on its own in the denominator, so we can times the bottom and the top by negative 1. So that's going to give us negative a. Oh, it's getting messy. All right, 1 minus 1 plus r to the n over r. And now we need to distribute the negative inside this bracket. So we have a to the negative 1. Let's just put the negative 1 over here to the negative 1. And then this is going to be made to a positive. So we have 1 plus r to the n can't write this like that. Okay. Divided by r. Okay, so this is the formula we end up with, which is our future value formula. And you can do this by hand, but you're going to see that this is what you get. This is a really simple way of, instead of writing out this nasty long annuity sequence, you can just use this instead. Once again, let's just kind of brush over this again. Once you have your series of cash flows, you need to identify that they're going to be earning interest, and you need to see that there's a common ratio. If there's a common ratio, then we can use the geometric series formula. Plug our common ratio into the geometric series formula, and we end up with this. Okay, that's the theory behind the formula. Let's see what this looks like in practice. Well, here is a spreadsheet calculator that I've attached in the link below, and on with the rest of the resources. You can use this spreadsheet however you like. This is a recurring cash flow. Assuming we're receiving, assuming I've done it in 2 stages. One, we're assuming we'll always have the exact same cash flow for $100, and the second, where it's not so much an annuity, but where we can change the cash flows as well. So you can change your numbers here. Instead of $100, maybe receive $150 or something, and you can see how much the future value is. And this formula is the formula that we just derived in the video. And this is more of a breakdown where we don't actually use the formula. I'm just adding them up, where we have our cash flows here. We add some interest for all the periods, and then when you sum up all of the cash flows, you end up with this.